Thank you, Leslie, and thanks everyone for being here, and thanks for having me. It's a great pleasure. First of all, please interrupt myself whenever you want. You can ask questions, and I'll try to be concise. And thank you as well for the great questions that you sent me. Are all really interesting, and we'll try to work it down. So I'm going to talk about water. I don't want to be too ambitious here, but water, energy, climate change, and entrepreneurship. It's too many things, but I'll try to, to give you an idea about some of these things. I'll focus mostly on water. I have been working mostly on water issues, but I'll explain other issues as well. Let me start talking about my organization. We are a non-profit organization, the Public Policy Institute of California, and we're a non-profit organization, and our mission is to inform and improve public policy in California through independent, non-partisan, and objective research. We are a research organization. And I think that there are some questions asking about that. I'll try to answer a little bit about this later. So let's start with presentation. As an outline, as I said, I'll focus mostly on an overview of the California water system. And I will do 3 blocks of that. The first part is just an overview. After that, I'll talk about the drought. I think that you are kind of interested. And I'll finish working a little bit about water economics. I'm kind of biased because I like that a lot. And we'll talk about a little bit about that. The second part is the water energy nexus. I developed my dissertation on the water energy nexus. So I'll talk a little bit about what are the relations between water and energy. After that, I'll talk a little bit about global change. I called that global change here. I'll explain you what I mean with global change. And finally, I will present some interesting entrepreneurship ideas. There's some projects that are already developed. I'm not going to give you no, but there are some interesting things that I think that I know because I'm in this kind of world, and I think that they are very interesting. So let's start with the water system. California is part of a Mediterranean climate, and because of that, we have 2 main characteristics. We have the first characteristic is temporal variability. We have dry years, we have wet years. We almost don't have normal years. It's always above or below the normal. And what it's even worse is that we have cycles of that. We have 3-4 years, for example. We are right now in the 4th year in a row of a dry year. You can see that there are other also, for example, look at this 1915, 1935. It was a really bad cycle there. Almost 20 years of very, very dry years. So we live with that. We have to deal with that. The second part of this thing is that there's also spatial variability. 70% of the runoff in California it's occurring north of the delta, and 70% of water demand lies to the south. Mostly, for example, in the urban side, 2/3 of the population lives in San Diego and Los Angeles area. And also we have a lot of very high value crops in this really dry area of the southern Central Valley. You can see here all this red area, it's 0.1% of our runoff. It's 30% of our territory. So we have temporal variability, spatial variability. How we deal with that? We built in the last century mostly a really impressive, a highly engineered water system. We built a lot of water reservoirs, and we built a lot of canals that are conveying the water mostly from north to the south, to the southern part of the Central Valley, and also to Southern California. This system has different, the canals are from different owners. We have state canals, we have federal canals, we have even local conveyance infrastructure. Like the water that we drink here, also in San Francisco, is coming from HH Reservoir in the close to Yosemite, and this is a local infrastructure. All this impressive infrastructure has a really interesting, I don't know if you can see that, but it's here. We have the delta. It's more or less the hub of that system, because most of the water that rains in the north has to go through there to go to the south. And this is a really fragile system. We call that a precarious supply hub. We have a lot of levees there because when we developed some of the agriculture sectors there, we just try to squeeze the rivers with these levees. And we have some parts, all these red parts, all these parts are below the sea level because we had subsidence there. After that, we also have a fragile ecosystem. We have a lot of fishes. Some of them that are even in sharp decline as well some of them are endangered. And we have also water birds there. And we have to take care of all that, all that ecosystem and work with an anthropogenic also supply hub there. But who uses the water in California? Accounting for anthropogenic and also non-anthropogenic water uses, we have like 50% of the water used by the environment, like in stream flows and for wetlands and others. 40% of this water is on farms, is used on farms, and 10% of the total water in California is used in cities. Most of that water is, it's not consumptive use. Environmental is not consumptive use. Most of urban uses are returning as well to the stream flows, and also water in the farms. And I will make a point here. You can think that 10% of the total use on cities is a very small percentage, but I would like to tell you that the average per capita water use in California is 108 gallons per capita and per day. That's almost 400 liters per capita per day. And just I would like to tell that it's between 2 and 3 times the per capita water that is used in most countries in Europe, for example. We are using twice the water there, mostly because we have a lot of outdoor use and other cultural things. But this is a good news, a little bit. Fortunately, California's economy doesn't rely anymore on water. In the beginning of our modern era, in the 1850s to 1950 more or less, we had a lot of mining, a lot of agriculture that were the most important sectors in that moment. But right now, non-recreation services and other goods are the really important part in California. That doesn't mean that of course, we don't have to care about that. Even that the California ag GDP, it's only 2% of the total GDP. It's there's a really important sector that there are some counties, for example, in the Central Valley, where their economies relies a lot on that. So it's really important. Given that, let's pass to the second block, is the drought. We are in our fourth year on a real severe drought. 2011 was a really wet year. We had a lot of exports from the Delta to the south, but after that, 2012, 13, 14, and 15 were really dry years. I'm accounting here water years. It's from October till September. Then 2015 is till this September. They were really dry years, and we are using most of our reservoir storage. And right now, not right now, but before the summer, we were almost in the same level that was in 1977. That was a really, really tough drought as well. So when we can't have access, or when we don't have surface water storage, what we do in that moment, usually in California, traditionally, we substitute that water, that surface water, for groundwater. And this is from the 1920s. What we can see here is that in some basins, mostly in the Tulare Basin and Saucon basin, we have been overdrafting the aquifers, almost every year in the last 80 years. That's even worse in this, you can, I don't know if you can see here, this is the droughts, and in that moment is when we overdraft more the aquifers. I'll get back to this a little bit later, but it's kind of a buffer of a security or insurance that we have, but we have to take care about this. What we can learn from the drought, there are some good news. There have been limited urban problems so far, and we have had a better performance thanks to planning, investments, and other things. But there are some bad news. Of course, there are painful agricultural reductions. There are very, very hard emergencies in the small communities. We have an environmental water crisis that we have to deal with. Talking about urban, why urban didn't have this kind of big problems? Mostly because we had also a tough drought in the 87 to 91, and in that moment there are some big cities that had really that have to deal with big problems, and after that they thought that it was worth to invest in new infrastructure, in conservation measures, and regional cooperation to increase their reliability. So the problems in the urban sector after that were more or less predictable, and they have dealt pretty well in this drought. But we have to look forward. Our supplies now are more constrained. We don't have much more water to take, and at this kind of cost, we can have other kind of sources. We have, for example, pricing restrictions. One of the most important policy in the urban side was this tiered water rates, when as much as you consume, more you pay. But now that's under question because there's a lawsuit in San Juan Capistrano. We have to deal with that, and we have also water quality problems in some areas. And what about agriculture? This is the result of Economic Research Service, the USDA, for statewide California. And what we can see from 2010 to 2014, that it's kind of astonishing, is that they have increased their, the total revenues have been increasing, and only because they have increased expenses, this red line. Finally, only between 2013 and 2014, the net farm income decreased a little bit. It was not super hard. Why was that? Because when farmers don't have water, what they do is just the low value crops. They just follow the low value crops, but the high value crops they still go working with them. So that's what we have been seeing, and there's another variables included in this equation. We have also crop prices that have been increasing in the last years. We have as well technological change that is increasing yields and other things, and they could deal. This is like a big picture of the state, but I wouldn't be fair if I talk about this, because there are some parts in the state, like the southern Central Valley mostly, where they rely a lot in imported water and groundwater that have been hit a lot. In southern Central Valley, Tulare Basin and San Joaquin Basin, they couldn't have other sources of water, and that's not their situation. They have been hit a lot. And for me, this is one of the saddest stories in the drought. 2015, California is one of the richest regions in the world, and there are some small communities that have had problems to have water, and there are other small communities that had water but was of a really, really bad quality. This is small systems with contaminated wells and health violations in 2013, and that's dry domestic wells reported in April 2015. This is one of the, among others, but this is one of the things that I think that we have to address in a closer future. But about the good news, the drought also motivates progress on some other fronts. I have been talking about groundwater depletion. We have had a lot of this groundwater depletion. Groundwater depletion causes a lot of problems, like, for example, this disconnection between aquifers and streams and rivers. And you can have a disconnected river that does not have environmental flow anymore, or many other things. For that reason, the legislature passed last year the Sustainable Groundwater Management Act, and for that, the water districts have to implement groundwater sustainability plans in the future. Then, for the only thing is that we have to implement that programs, and they have to achieve sustainability by 2040. It's kind of a long way, but at least it's a step to deal with this problem. And with that, I think that we are done with the drought things.
Mm-hmm. The subsidence, the levees, the things that are below
yes.
sea level, is this from drought
yes.
to groundwater?
Yes.
Yeah, so it's only getting worse.
Yes, but there's, it's not only because groundwater, is because all that land in close to the delta had a lot of organic matter there, and they burnt out. But also, because agricultural practices and groundwater depletion, yeah, that was the cause for that subsidence. Let me talk a little bit about water, water economics in very general way, but I think that it's really interesting to think about this. Water has to be treated as a public good because, public good in economics is something, it's a good that it's non-excludable and non-rigorous. We all can use, can go to Yosemite, can swim there, and we are not competing with that use, and we are all enjoying of that use. Water is also needed for life, for our life, or for environmental systems, also for recreation systems, and it's a part of mankind collective heritage. And for that reason, water is, of course, a public good. But on the other side, water is also a commodity. Water has an economic value in all its competing uses and should be recognized as an economic good. This is the statement, the fourth principle of the Dublin Statement on Water and Sustainable Development. And what I'm saying that, farmers, energy, the power sector, and other industrial sectors are using water to make profit. And, I think, beyond life necessities, there's an economic use of water in households too. We are, when we are irrigating our lawns, that's not, it's only because we want to be kind of more happy, and that's kind of an economic use of water. In this case, if water has this economic value and we are making profit of that, the society has to look for economic efficiency in water use allocation. We have to allocate the water for kind of more valuable uses to improve our society. And this is kind of part that I'm encouraging you to think about all the small parts that we have in these water systems, that there are many opportunities, mainly, this is my view, mainly focused on economic and technological tools to kind of look for more efficient way to manage water. We have efficient technologies, there's a lot out there, but I think that there's many other that could be implemented. There's economic incentives like water pricing, subsidies or taxes to do an efficient water use. We can talk about providing information. People need information to know, probably people usually don't know how they are paying, how much are they paying for water. It's so small that they don't care about that. It's a very small part on your monthly cost. We have to understand behavioral attitudes, why people behaves the way that they behave, and after that you can try to modify that behaviors or all that. We have to value environmental resources. If we value environmental resources, we can assign a cost. We can assign, for example, economic incentives to valorate that. We could propitiate trading if water is an economic commodity. It's a commodity. By trading it, we can get more a useful allocation. We have enhanced markets. We can as well reveal market failures. If we know that there's a market failure and the market can't allocate the water in an efficient way, we have to reveal it and we have to deal with that. And finally, we can decrease hurdles with better policies. With that, more or less, is the first part. I'll talk now about the water energy nexus. This part will be a little bit about my dissertation, more or less. And to understand that, when I'm talking about water energy nexus, I say that in California, 19% of all electricity and 30% of all natural gas is used to extract, move, treat, and heat water. That's a big amount. That's stated in the California's water energy relationship of the California Energy Commission report in 2005. And this is energy for water use. On the other side, we have water for energy use, for energy generation. Sorry. Water withdrawal for power generation amounts 45% of total withdrawals in the United States. That's in 2010. This is all the states from west to east. This is California, the largest one. We don't have that kind of problems here. Very few of our water is going to power generation, and most of this water is saline water, is from the sea. So we are not competing users. But there are some other states in the central part and eastern coast, the east coast, that they have a lot of water is going to thermoelectric power generation. I have to say here that most of that water is returning, is getting back to the system. But anyway, we have to, these power units needs a reliability in the future to have that water. So we have to include that in our, thinking. So water and energy are interrelated in many ways. For example, we have dams. The dams can produce hydropower. There are other power plants that need water, as I said before. And in the other side, water pumping, moving water large distances, water treatment, wastewater treatment, and watering houses. We use a lot of energy there. We can see the third leg of that nexus that is called water energy food nexus is the food production. For food production, we need a lot of power and a lot of water. So, there's kind of a very complex system to understand. In my dissertation, I worked a bottom-up approach from households, after that urban systems, and after that the basin scale. I'm just going to present very briefly the main results. This is for the household scale only for heating water. Heating water in our households amounts for the 2% of total per capita greenhouse gas emissions in California. Most of this energy is used in faucet and shower. 80% of our water-related energy is in faucet and showers. And as you can see here, most of the water goes to outdoor, and they have the other components of. I accounted as well for the costs, trying to know which conservation strategies are more interesting if you account for energy conservation. Because I think that when people is using water, they don't think that there's a lot of embedded energy behind that. The second part of the dissertation was analyzing the urban water cycle. This is a really simple schema of East Bay MUD. East Bay MUD is East Bay Municipal Utility District. That is here the utility that serves Oakland, Berkeley, and other cities there. They have 1.5 million of customers. And we have the dams there upstairs, and we have to treat the water, pump the water to that hilly topography, and after that, treat the wastewater. When accounting for all these things, I found that the urban water cycle as a whole is responsible of 4.5% of our per capita greenhouse gas emissions. And you can see here that most of that greenhouse gas emissions are end uses, single family, residential, multifamily, and commercial and industrial. Only that 5% is water treatment, pumping, and wastewater treatment. Only 5% of the total urban water cycle. But what is important from here is that for the water utility, that 5% it's worth $12 million per year. This is for SBA money. What I was interested in that, it was not only to assess this, it was what are the consequences for the water utility and also for the energy utility if people change their behavior, if they are changing the way that they are using water, the patterns, the time patterns of consumption and other things, because they can have a lot of changes. Yes?
What is the distinction between single family and multifamily?
Single family, it's, multifamily is a kind of apartments, and residential where water is kind of for a group of houses. And single family, it's only your family, you have one account for yourself. Then, the last part here was understanding the basin scale of that. We have water, yeah, sorry.
Did the analysis of greenhouse gas emissions for water use, did that just assume that every watt of energy is a certain amount of greenhouse gas emissions, or did it take into account time of day when people were using them?
It doesn't take into account time of day. It's what I did here is using greenhouse gas emissions factors from the utility. In this case, it's from PG&E because it's the utility that is serving, but it doesn't take into account different times of the day.
So if these sorts of uses could be shifted off peak, then wouldn't they potentially have different greenhouse gas emissions related?
That was my motivation, but not for the greenhouse gas emissions, because I will explain later that. But my motivation was that there's a lot of costs of that peak, the afternoon and morning peak. If, for example, there are people that it's irrigating on peak hours because they don't care. You are paying the same. What if we can change that behavior to off-peak hours? And I was accounting for costs, for costs for the energy utility and the water utility, because the energy utility is serving the energy at the same price, and they are paying a lot. The other part is what you are saying. Greenhouse gas emissions are different in the time of the day. I have a kind of the feeling that we can't do. I have seen a lot of some of the research that is doing what you are saying. I have the feeling that if you change that peak, what is happening is that the system reallocates the way that they are using all the power units. And in this case, you can't say directly, we are saving because we are not using the peak. Actually, in peak hours, we have the less pollutant power units because we have solar. And it's kind of tricky. There's many issues there that have to be accounted, but that's a good point. I was thinking about that as well when I did that. And the last part of that was to account for the basin scale. We have, if we account for a basin that is a closed system, all our water sources are interrelated between them. We have groundwater, we have surface water, we have recycled water, but they are interrelated, and we have to account in a hydrological or in a mass balance system to account for their interactions. And these water sources are serving to cities' ag demands through utilities or through self-supply, but also to the environment and to power, to energy generators. And from the energy power units, from the power unit, we do energy to the grid, and we get back to this. We have a really complex system here, and understanding that complex system is the first step to try to manage it in a better way. I'm so sorry, but I don't have time to present most of the results, but what I found here, this is very simplified model for California from 84 to 2003. And what we found here is that most of that is the urban energy, first. 5% of the total greenhouse gas emissions are from the total water cycle, because most of that is the urban. 85% of the total is coming from the cities, from the urban cycle. We have here that this red, more or less red and yellow, is they are the urban cycle, and after that we have the ag, and also a large conveyance. This big peak is the State Water Project. The State Water Project is the conveyance infrastructure from here to LA that goes through the Tehachapi's and has to pump a lot of water. So we are using that, this 11% of our greenhouse gas emissions in my model would come from there. 11% of the total greenhouse gas emissions related with the water. Talking about that because it's not super big, I was saying the phases, but the State Water Project is the largest single user of electricity in California. Some years they can use 3% of the total electricity in California. They are generating electricity after that. They pump the water, and after that they recover some, in this case, but as a single user, they are the largest one. Not this year because they don't have water to pump, but. And just the last slide here in the Water Energy Nexus, this is the other side is the generation side. I just wanted to say here that hydropower cut in half by the drought, was cut in half by the drought, because hydropower is highly variable depending on the water that we have. And this last year was half of the average. What is happening here is that because we can't build more dams, all the good sites has been built already, and we are increasing population, increasing energy demand. We have a lot of other electricity that is coming from other sources, and in this case, hydropower is not really significant now. But still, there are some studies that say that probably 2% of our increase in electricity this year are coming from decrease in hydropower. And with that, I'll talk a little bit about global change, and I'll explain now why I call that global change. I really like this quotation. Global scale changes in population and economic development over the next 25 years will dictate the future relation between water supply and demand to a much greater degree than we will change in mean climate. That's our paper in Science. What I want to explain here, I look in the face, it's not. What I want to explain here is that, of course, that we have to take into account climate change. Climate change is kind of our availability. Our temperatures, our precipitation is going to change. Our patterns are going to change a lot. But we have to take into account our demands and population and how we as a society are developing. It's a really important part of our models. Then, after that, probably you have seen this before. This is California is getting warmer. This is temperature. Last year, 2014 is the warmest year on records, but by far. And what's that causing in our systems? More warmer temperature causes more evapotranspiration. We have less water usually. We can think about energy as well. Warmer temperatures in summer increase a lot our air conditioning demands, and in this case, increases energy demands. This is really important for water systems. Climate models are predicting a shrinking in snowpack and a lot of increase in variability. Snowpack is kind of our natural reservoir. It's snowing in the winter, and we have the snow there, and in the spring and the summer, when we use the water, when farmers mainly use the water, this snow melts, and we have that water available. If we increase our temperatures and some of that snow falls as rain, we'll have to deal with this water before. And we'll have problems with our reservoirs because we can't, some of the rain that is falling on winter, we just have to release it because we have to have a flood storage capacity. In this case, this is going to change a lot how we manage our systems. The other part that you already know is that sea level rise threatens coastal infrastructure, homes, and habitat. This is the worst case scenario for 2100, I think. A 55-inch sea level rise will put nearly 500,000 residents at a high risk of flooding. We have as well critical infrastructure, airports, roadways, and also habitats, environmental habitats will be affected. This is the kind of supply side, the availability. But when we talk about demand, this is about, we're talking here about water. This is from the DWR, California Water Plan update in 2003. We are expecting in 2050 that our irrigated crop area will be decreasing slightly. Why is that? Mainly because we will have more population, and these people has to live somewhere. And this, mostly in the Central Valley, growing cities will displace crop areas. In this case, we'll have less crop area, more population, and as we use a lot more water per acre in farms, it's expected that the total demand in the future will likely be kind of similar to now. I would say as well here that we don't have more water in this case. We'll have to deal with that. We don't have fresh water. We can talk about saline water later. And what will happen with agriculture? This is a study from my colleague of Medina Suarez at UC Davis. This is the economic impact of climate-related changes in California. We can see here it's two, the historical climate is the yellow, and the green is a warm, dry climate change scenario. We can see that the irrigated acreage will decrease a lot, the farm water use will decrease a lot, but the revenues will decrease, but not so much. Actually, will increase in the future. Will decrease relative to the historical scenario. Why is that? It's because the same that I said before, we will see displacement in low value crops. Low value crops will be getting out, and we'll still have high value crops, and we'll have increase in yields potentially because technological change and other things. That's what we are likely to expect. And finally, this is another sad story. We have a really an aquatic ecosystem crisis. Till 2010, from 1975, this is fishes, freshwater fishes in decline. Freshwater fishes. We have extinct as red, highly vulnerable, less vulnerable, and least vulnerable. What we have been seeing till 75 to 2010 is that the less vulnerable fishes that are okay have been reduced from 56% to 22%. We have increased a little bit our extinct species from the 75. And if we run the same way that we are running right now the system, we'll expect a lot of more extinct species in the future. So we'll have to think about that. And finally, that's your point. Interesting entrepreneurship ideas that I found through, I'm only going to show you 4 cases. First of all, I would like to ask you a question. We are talking about drought, about water crisis and all this thing. How many of you think that you are aware about your water consumption, and because of that, you have reduced your water consumption in the last years? Please raise your hands. I'm included. Okay. It's a tricky thing. there is little or no correlation between general awareness of water conservation issues and household consumption. This is a study in 2003, potentially, yeah.
Haven't California really reduced its
Yes.
water use now? So,
Yeah.
I mean, isn't it like people are aware of
Yeah,
it?
yeah, but what this study that I really like a lot, it's just to motivate thinking about that, is that there's no correlation. If you take a sample and you ask how environmental friendly are you, and you say I'm a lot, and there's other people I don't care. There's no correlation about these people that are saying that it's super. At least these guys didn't find it, and of course that we can think about that. I just use that to motivate. But if you want to.
But there's information now that Cal Water, for instance, gives you, and you can see.
Yeah.
We stick it on our fridge.
Yes, but I'm also taking that. You'll see in the next slide. Because of that, it's like individual behaviors or what people think about themselves. If you can't compare with others, it's not a valuable approach. And finally, but our findings substantiate the role of personal involvement and habit formation. Habit formation is really important. And it's this is the first case study, it's WaterSmart. Probably, I don't know if it's here, it's in Davis, it's in other many areas. WaterSmart is a company. What they developed in the last 5 to 10 years is just they are doing a portal, they are working with water utilities, and what they do is every month they send you an email or a letter. I think that email works better. And, and they are saying, hey guy, you are a good guy or you are a bad guy. And they are just very simple thing. They are your water score can be green, yellow, or red. And this is because they are comparing you and other houses that are like yourself. How many people is living in your house, the same, how big is your plot, and all that. They are more or less comparing the same things. And what they have found is that they are creating behavioral change by enacting social norms. People like to act as normal people. We are most of the people, not everyone, but most of the people like to be in the normal. And when they are telling you, you are using much more water than others that are like you, you'll have to take care about that. They in the webpage and in other studies that I have found that are interesting, there's a very cost-effective option of water conservation. For example, in SBMAT that I was working with a sample there, they say that in 1 year they reduced by 5% the total water consumption in SBMAT. It's only information, what we were saying before. Information in the kind of right way, in a very easy and understandable way. The second case study is also a platform. It's called Waterfine. It's an Australian company. I think that they are now here in the US. They are working a little bit. But this was developed before, I think that in the 90s or in 2000, the beginning of 2000s. And what they did is they developed also an online platform, and they act as a broker in the Australia water market. And what was that? Why was that? Because they were, this trading. Australia has a market, an enhanced market. They developed it in the 80s. And the trading before was only by personal agreements. People that go to one place and say, I want to buy your water because I have higher income from my use. In this case, what they did, what they find is there's an institutional thing that is not working because it's not really useful. But with online platforms, they can get together people that wants to sell water and people that just want to buy water. The third one, I think that you will knew it, is Nest. I think that what they are doing is just very easy. 40% of residential energy consumption is space, heating, or cooling in the United States. That's data from Residential Energy Consumption Survey. I would add here about the work that I did before that 25% in California is heating water. It's less in other states because we have less. We have less heating and cooling here in California because we have a mild climate. But it's a smart thermostat that learns about your habits and just changes or tries to optimize the energy consumption of your house. And the last one, I think that it's based on this thing. It's not still out there thing. I was reading that they will start to be sold in December. I think that it's more or less the same, but in water. They are using a whole house water controller, and they are providing information about your water use. Kind of more detailed information about how much water are you using outdoor, in other parts indoor, and in other appliances indoor. And it can automatize uses according to weather or other conditions. I think that's a really interesting idea. We can get some benefits from there. And I think that I'm almost done. That's a nice cartoon. This is from the 90s. This is from 91 drought. They were saying that we can become something like that because we won't have in the future. And you have our permit to use our slides, and you know more information. You want more information, you just need to ask. And with that, I'm done with that. We will follow with the questions, right?
Great, yeah, perfect, thank you. So we've sent the questions in advance that you folks have submitted, and there were some great ones. And also, of course, as always, feel free to just ask real time.
Yes, please. Yeah.
Any of the things that sort of help you track your water use and that sort of thing, do they account for your food preferences? Because you showed that of the anthropogenic uses for water, 80% of that was for agriculture, and only 20 went to direct use in homes.
Yeah.
So I feel like my parents use as much of California's water living over in New York as I do living here because they still eat almonds.
I think that we have a kind of similar question of that here. I can answer that now. This is the so-called virtual water or water footprint of things. There's a really interesting idea from Hoekstra, I think in the 90s. It's a paper, I don't remember the name now, but it's Hoekstra that developed that idea about virtual water and water footprint. I think that it's a really interesting idea when we account for kind of international trade and also for, when if it's worth to use something here that is produced somewhere and is transported here, and we have a lot of greenhouse footprint inside that. The same is in water. That's one point. I think that it's really interesting to think about that, and probably there's a lot of implications of that. The other point about, for example, the almonds, I think that was we wrote about that at PPAC in our blog, I think. It was a New York Times news article about almonds in California. If you think about kind of microeconomics, I was telling before, a farmer just wants to produce what is more profitable for themselves. And almonds is one of the most profitable things right now here. Probably in the future won't be. But what I mean with that is that you can't avoid that, and it's not bad. At least from my understanding, they are creating jobs, they are doing other things. Water here, we have the water. The water is getting back to the water cycle again after the consumption, and I think that we have to use our resources as better as we can. If a farmer can pace another, for example, we are growing rice here in close to Sacramento. Rice is the most water-intensive user, or one of the most intensive users in California. if a farmer can change or can trade their water use with other use, for me it's not a problem. Taking into account that we are not accounting for environmental things or other kind of, because rice, it's providing ecosystem services as well. But that my impression is that we have to account for all these things and use our resources as better as you can. And I think that thing about the almond is it's an interesting idea. I think that in an international way, but not so, or in a national trade way. But when you ask the farmers, it's microeconomics, I think. I don't know if I answered your question, but it's my feeling about that.
In terms of individuals who want to reduce their water consumption,
that's
I know that almonds use a lot of
that's completely
water,
fair.
But are there any tools that would help me? Because I can take a shower that's 5 minutes shorter than it would otherwise be, but is that a meaningful contribution relative to changing my diet?
Yes, but for example, what I feel from your question now, let's talk about beef. Beef is one of the most consumptive resources that we have. When we eat beef, there's a lot of water, there's a lot of other resources there. Also land, the cows needs a lot of land to be grown. Then, if you think about the global thing, probably we are not sustainable. If all the humans eat the beef that we eat, we couldn't afford that. And we have to think about that for the future, probably. But it's kind of the same for water if you account if you think about that, if you think in that way, like how much water. If we are having a footprint that the world can't afford, we will have to think about this. Most of that almonds are going to China. That's another, it's just international trade, the way that it's right now working the international trade, yeah.
Kind of about that question, I think almonds are unique because virtually all the world's almonds, I guess, are grown in California, but for a lot of products just regular old milk, right? Milk is a pretty water-intensive product by itself. Do you think that it would be useful to, for example, buy milk from Wisconsin where they don't have a water crisis as opposed to buying milk from California, right? Because where you get these resources is going to make a difference in terms of the various pressures, right? And some areas are better able to handle the ecological pressure of limited water, like the east coast of the United States, Wisconsin, New York, etc., than California. Is there a way to kind of do that to make a more meaningful contribution, to use kind of globalization?
Yes, I think that's a good point. I think that the market kind of regulates that. What you can't do, that in some crops we are doing, it subsidize kind of things that are not working because the market. We are doing this thing here in California and also in the United States respect international trade. We have to think about it's useful for us to create a sector that actually is not economically feasible here. And I think that's a good point to think about and actually dairy has a lot of trouble right now not only because of that, also because of that California has a lot of environmental regulations that dairy, that other states doesn't have, other states don't have. And they probably are better to go there just because they can contaminate aquifers. And here we have a very restrictive, but that also, thinking about as a global perspective, it's not also helpful for anybody. It's the same, it's just relocate kind of bad things. It's not a good approach, but we have to think about that. More?
So you mentioned about water resource management and changing people behaviors to use less. I guess the desalination plants would be last resort, or what's the current position of desalination?
What's happening with this? I think that's another question here. What happens with desalination is that right now it's so expensive that for most of the users in California are not, farmers are not going to pay the cost that the cost that the salt plant needs to be run. Then in the way that are working right now, the only potential future for desalination plants is for urban users that don't have other sources of water. If they can get water from other cheaper sources, they're not going to build a desal plant. But if they have, like for example, Israel or other very stressed parts in the world, if you don't have other resources, you'll build a desal plant. But here in California, there's another part. There's some projects about brackish desalination. You know, brackish desalination, it's not salt water, it's not so intensive, and you can do that can be affordable or feasible economically. More? How the time we are limited?
We've still got 13 minutes.
First is your question: how do agencies such as yours evaluate possibly fund testing areas for new technologies that have promise for helping with conservation and water efficiency? Do you track accelerators like Clean Tech Open, Sustainable Silicon Valley, and others? And do you have any advice? My advices were before, more or less. And, my advice, the advices that I have to give, I did it before, I think, more or less. But, what I mean here is that combining two things about my presentation is that these complex systems have multiple parts. And also this kind of microeconomic theory, at understanding how people behave, how farmers do their business. Understanding these both systems, there's many points where we can help and where we can be useful, I think. And I think that there's a lot of opportunities out there. And in a water-stressed region like California, probably. In other parts, they don't care about this because they have water. About our organization, we have been, we are not directly tracking accelerators like Clean Tech Open and all that, but we have worked a little bit, or we have been following some of these companies. For example, it's not this kind of new entrepreneur companies, but in the 90s was a really, at least in my area, a really famous company. It's called Aquacraft. It's in Colorado, I think. And what they did is that they just used a water meter, a pressure meter in the main intake of your house, and they developed an algorithm to understand where are you using your water in the different appliances of your house. Most of my dissertation was based in that company, that data. Other companies, as I said, Water Smart is doing really interesting things. And for next year, we are just now working in a project to analyze drought resiliency for the next drought in California. And one of the parts will be working with with urban policies. Which policies have been more cost-effective in the future? We can think about this, and of course, I think that in the future we'll have to account for these things. Most people in California are aware of climate change and the impact of most choices. However, people do not seem to be as conscious about water consumption from our daily activities. Concerning the water shortage in California, do you think that it's possible to actively, not passively, change people's behavior, daily behavior to save more water? If so, what is the role of policy and mass media? I think that, this was also about virtual water. This says a store-bought cup of coffee requires many times more water during the entire, It's also the thing about virtual water and water footprint. I think that we can change a lot of things, and also, the most promising thing for me, if we want to reduce urban use here in California, is outdoor. There's a lot of outdoor consumption here, and even more in Southern California when we have warmer temperatures and all that. But also in indoor things, think that there's kind of big percentage between 5 and 10, even in really developed countries, between 5 and 10% of water is leaking in urban water systems. There's a lot to do there. How can an organization be non-partisan when the parties are so clearly divided on just about every issue? How the think tanks are funded and what we think about. What we do is research. We have a board that tries to have everyone included. Both parties are included in our board. We have different stakeholders. We have farmers. We have urban, for example, we have the president of ACWA, that it's a Association of California Water Agencies. It's in our board. And for example, my role there, I can propose projects that I think that are policy-oriented and interesting. And if they think that are interesting, I can work for myself, like developing research. And this is the way that we work. Being nonpartisan, it's sometimes difficult. You have to say things that people doesn't like, but at the same time, you have not to be an advocate of because they have to take you into account. If you just say things that they are going to hate you, it's not working. You have to be between these two lines. I think that's my thing. And day-to-day work is that I just do research like before. I don't have to. I'm not teaching. I have more time. How do you address untangling the issues of the century-old land ownership? Okay, this is about water rights. It's asking, I don't understand fully how water is allocated to given a farmer, and how do you determine now who gets the water? It's water rights. Water rights in California, in a very simple way, we have 3 types of water rights. We have riparian water rights. Riparian water rights is people that it's just next to the river. This is the first water right that exists in California. And the riparian water right is the first that gets the water. And they get all the water that they want, but they are just close to the river. And historically, they have been doing so. And there's 2 kind of appropriative water rights. That's after the mining era. Appropriative water rights that you ask a permit for the government to get water. There's pre-1914 and post-1914, because there's a change in the legislation that time, and pre-1914 have more privilege on water right allocation. Then, it's a great joke that a friend of mine did. If you have 3 glasses of water or wine, and there's one appropriate, one riparian, one pre-1914, and one post-1914, you have 3, it's 1 for everyone. If you have 1.5, 1 is for the riparian, and the other half is for the pre-1914. And post-1914 doesn't have anything. It's really complicated, and it's a really tricky system. One of the projects that we are working with right now is, we think that if we could change that, we will propitiate more trading, and that's kind of beneficial. Because, for example, riparian, it's said here. Riparian gets the water as much as they can, and for that reason, they are just saying that they are using a lot, even though they are not using that water, because they want to. So sometimes, like this year, in your models, you are accounting for this use that actually is not used, and you are kind of wasting that water. That's kind of tricky. What measures is the Californian government agencies taking to bring this into practice? They are doing a lot of things. Actually, our role here is much easier. We just can propose things. We don't have any responsibility with voters, with other things. They have to deal with all the bureaucracy and also with the voters. But they are doing a lot of things. For example, last year they implemented that sustainable groundwater management with a lot of opposition. There was a lot of people that didn't want to implement that because they were pumping a lot. And this is kind of, didn't understand well, it's about the macroeconomic thing. What it's evident that they are gaining huge importance in today's world. How true is the El Nino would be the year of El Nino for California? And this is something that I have been eagerly looking forward to a while. There's a NOAA video out there. It's really, I can send you the link that explains really well this. And what is happening is that in the southern part of the United States, it's likely to be it's wetter, but also warmer. But it's kind of tricky for us. And in the northern part, it will be drier. Then, I think that most of the most likely part, it was Southern California, was about 50%, for California, not for the rest of the United States. The likelihood was about 50%, I think that in really Southern California, and about 33% like from Sacramento down, something like that. But there's a video that you can check. I can send you the link. Yeah. Desalination, I think that I answered that question. I saw in your blog post that, and that's good because it's my first one, SB 350, and I'm curious about what sort of technical breakthroughs you think would be required for its success. It's technically feasible, but costly. Do you think that the state would fund these efforts? That's the point. It's like I think that technically we can do it. The point is, it's economically feasible, and it's actually true that it's going to result in a lot of jobs, and it's a trade-off between things that are on benefiting the California and other things that are also costing a lot of things. Well, there's another point, but it's not related with that, is that California is playing a kind of leading role worldwide. And we have to think, how interesting is that for us? I think that it's really interesting, but probably it's costly as well. If everyone follow us, that's perfect. That's really good for us, and in the future we will have a lot less troubles that we are expecting. But of course, that it's we have a lot of sectors interacting here. We have the green economy, we have the fossil fuel economy, and we have the voters and the politicians. This is so difficult. What are some of the unanswered questions of the large and the small scale on your field of work? One of the most thing is, that's really tricky to explain. There's a controversy about surface water, about irrigation technologies, surface irrigation and drip irrigation technologies. I didn't find really good research that is explaining how much of that surface water is returning to the aquifers. Because a lot of people say that when you are changing your irrigation technology, you are saving water. And that's not directly true. It's in some part true, but some of the water in California that we have this in the Central Valley, that we have these two valleys that are going to the same place, most of the water that farmers are kind of wasting is getting back to the aquifer and is used again for other users. Then we are not wasting that water. But I don't have data to say how much water, because I didn't find the concrete thing about that. Behavioral economics is, I think that's another topic, and applied to water and energy issues. It's a lot that is going on now, but I think that there's a lot to understand in the future, how people behave, and when an utility increases the price or many other things, like gives you information, how we are reacting to that. And I think that that's an interesting point. And this is more difficult, even more difficult. I don't understand that. With the degrading Sacramento-San Joaquin Delta levees, stronger El Nino patterns, and decreased spending on improvements, it seems it's now only a matter of when, not if, we should see a major disaster in this area, which could cause possibly billions in damages. While there is not an easy solution for this problem, what do you believe could be a first step or a solution to this impending crisis? I I think that we have to take small steps in very different areas. We have to take, we call that a portfolio approach. If you, for example, this is what urban utilities did in the last 20 years. If you only have one water source, you have a problem. If you have 5 water sources, your reliability it's increasing a lot. The same can be seen kind of big management problems. We have to have a portfolio approach. Could you mention some of the ways becoming involved in these projects? I didn't see in the beginning that I think that it's talking about Public Policy Institute of California, I think. We have internships in the summer, and if anyone is interested, I think that it's open in February or March, something like that. But check out our webpage, and we have that. We are almost done. We're only 12. What water and energy infrastructure improvements has found most successful in Spain? And based on this success, what improvements does he suggest California prioritize now? The most interesting thing from Spain, that it's not potentially applicable here, it's our institutional framework. We have, for water, I'm talking about water now. Our institutional framework, we have a basin agency that oversees everything and has a lot of competences, can curtail water, can do a lot of things that here you can't do that because you have this decentralized and local kind of management of water systems. These are, we can't go there right now because our California laws and all that, but we can figure out how to get a more comprehensive and integrated system to work together. And for energy, I would say that we have done a lot of renewables. There's a lot of wind and solar in Spain. It's developing here right now as well. At some cost, we are paying that in our electricity bill sometimes in Spain, I'm saying, because it's economically it's more expensive right now than other energy sources. For water, for example, much water in California, particularly in our Bay Area, is lost and or contaminated due to the deteriorating water pipe system. How can we staunch this inefficiency most economically over the next 25 years when replacement is projected to cost over $1 trillion? With small steps as well. I said before that there's a lot of water leaked in urban water systems, and I think that there's a potential technology issue there going on. I think that there's a lot of working in progress in that area, but it's a technology issue to know exactly where do you have your leak.